Hello developers, welcome to my video series on Microsoft Flight Simulator add-on workflow. Today we're going to continue with the process of making an aircraft add-on, and we'll continue to add interior gauge animations, and we'll make some of them work in the sim. We are using the SDK documentation and specifically the how to create an aircraft section, and we'll continue that process. We'll be adding needle movement, some dials that turn 360 degrees, like the airspeed, altimeter, all of the other instruments there that make some kind of movement with the needle. In the previous episodes, part 1 and 2, we made simple rocker and toggle switchers and levers. And in part 3, we talked about XML programming and decoded some of the templates. So we'll continue to use and build upon those skills that you've learned in those sections. We'll use the interior XML files again. Specifically, we'll probably use the instrument one for most of the templates that we're going to use. So I went over how we got certain parameter names and things out of that, and we'll use that information, put it into the blend file, and make the animation work. I'm going to leave the more complicated gauges like the control column or complicated gauges, the rudder pedals, as a separate episode. We'll just do aircraft gauges in this section. First, let's set all the textures for as many instruments as possible. I started that with the airspeed indicator and the attitude indicator, so I have the graphics for the faces of those particular gauges. And these are mostly Bendix King instruments, so I also did some of the ones I will do later. I did the rings around the outside, and we're going to start cleaning up the textures so that we can have something that more resembles the interior of the aircraft. And this will help a lot, and we'll be able to see the instrument and read the information off it. So the textures. So what we're going to do is we're going to get the face of the object. We can start renaming things. This is the vertical speed indicator, and that's the face. There is a needle in there. We'll find the needle, so VSI needle. And there's the glass. I think that's the glass. Yeah, instrument glass. So we can start changing all of the different pieces. And then we can use the same name at the beginning and at the end. And these are the main parts we need. So the face, I'm going to get rid of the default white. So we have nothing. I'm going to make a new instrument material. I'm going to call that instrument VSI. And we're just going to make that a standard. I'm going to change the metallic factor down to 0 and play with the roughness a little bit. This makes the face appear better. And the last thing we need to do is to actually find the texture associated with it. So the author was very good in getting that for us. The VSI, it's already UV mapped. So the UV editor, and I'll go in and get the VSI there in the animation. Oops. And even if we edit that, you can see that it appears here. So they've used the one off of the 10 there is the white part for the needle. So even the needle is set. And that's the face again, so the face here. And you can scale that up and down, move it, grab it and move it and make it appear closer to the center. Maybe we want to scale it a little bit, and we can scale that UV so that it appears better. So we'll do that to all the instruments. I'm not going to go through all of the instruments and show you, but basically that's what we're going to do. We're going to add a instrument and then add the face graphic to the standard MSFS material. One thing that you'll probably have to be aware of is some of the instruments have their origins not quite where you want. So you basically have to set the origin to possibly the geometry. So make the origin in the center of it, and here make that origin geometry. Oops, other way around. Origin to geometry. So put that in the center. That way when you go to the UV editing part and we edit that, come on, so slow today, that we can get this in the middle of the origin and the needles and so forth. We'll probably have to set up the needles also. So that too, the origin, I'm going to make it easy, set the origin to geometry, but that's not quite where I want it. I want it in there, so let's edit, turn off the normals, and I want the origin to be in the middle of that. So that, so Shift S, 3D cursor to selected. Not quite right. I think. Let's use the points. Shift S, cursor to selected. Almost. Yeah, a little bit off. So I'm going to move that. That's better. Do it that way. Cursor to selected. Yes, thank you very much. Tab out of that. Object. Origin to 3D cursor. There we go. So now we have, when we rotate this, rotate it in the global axis. There. So the animation will be correct. Okay, I've gone through all of the instruments. I've added the faces. I've renamed things. I've reorganized things. This is a lot of tedious work that we've done. So the airspeed indicator, ASI face, ASI glass, the altitude, glass, knob, needle, negative flag, other switches. We've got the VORs, This is the KI-227 ADF. We did the vertical speed, the turn and bank, and so forth. There's not very much to them. There's the turn and back face, the glass, and the face just has a standard material, called it instrument whatever, and then basically added the PNG from the file that we have. Textures. So all of the textures are there, the altimeter, ammeter, circuit breakers, the charge, the clock, DME, flap, fuel pressure, uh, heading indicator, the interior, all of the different instruments. I'm going to use the CAP 140, the KFC 200. I'm not sure. I don't think that's a real instrument. It's KI 227, KNS 80, KR, the KT, KX1 mag switches. We did that, oil pressure. We did the seats. I did the interiors also. So I made the entire aircraft look nice. So did the seats too, um, using the seat PNG, even that part, seat PNG, pedals, anything. The interior is just the interior. This is all pre-UV'd. All I have to do is set up the materials, the Microsoft Flight Simulator material, and you can see it has the node structure that we're familiar with. And you change nothing much other than you can change the metallic factor. Depends on how much reflectivity you want. You want it smooth, not so smooth, etc. So I've done everything here already, making the aircraft look nice. In our previous episode, we did the sun visor animation, so that still works, etc. So let's start with something easy. The airspeed indicator with a needle. The needle has a 360-degree rotation. And remember, I told you we needed to make the aircraft origin, or not the aircraft origin, the needle origin, somewhere where it can rotate, and it rotates around. Now I've got two animations here. Just one I wanted to try. I didn't have very good uh, luck with that. Um, I had 10 different positions. I had much better luck with a lot more. So all of the different 1 to 18, so 20 degrees or 18 times 2. So each one of these matches up to the 40, 50, 60, 70, 80, 90, 100, and I just left it off. So each one of these is going to be up to 180 knots. So every 10, rather than this one here, which was every 20. So just start at the vertical area and then make a instrument needle animation. In fact, what we'll do is I'm just going to remove that, and we'll do the same thing there, that every keyframe will be set. starting at 0. So I'm just going to X that out. Oops. X, X, edit. I like to remove any animation data. So it's start off at the vertical, press the I key and rotation. And that's your first one. I think we should clean up what we just deleted also. So this one here, that's why it adds the .001 there, because there's already an action with that label. I'm going to move over R, Y, and I'm going to say that that's the 10. I, rotation, move over, RY, 20. I, rotation, move over, RY, 30. Rotation, move over, and just keep doing this. Oops, move over first. And I'll make it 50. Rotation. And make this one 60. Rotation. 70. The reason I do it so fine detail is because you can notice that the difference between 40 and 60 is 20 knots, but the difference between 140 and 160 is also 20 knots, but this is a much larger span than this one is. So that's why I'm doing it so close. Forgot to move it over. 80, I, rotation, 90 is here. Oops, move it first. And you can see that I've done all of the other ones too, just so I can make sure that I've done them correctly. I'll just estimate that 180 is about there. Okay, I like to push this down into the NLA slot. And you remember from the previous section, we need to go into the Asobo instruments. And where is the airspeed? Probably at the top. So the instrument airspeed needle is the template we're going to use. It calls the subtemplate for airspeed, subtemplate. And remember that the name of the animation and node that we need in Blender is based on this information. So instrument, needle, airspeed, and a suffix. And the suffix ID was because we use the helper suffix, and it takes this ID and adds it to the end. And so in here, instrument, needle, airspeed underscore 1, and instrument, needle, airspeed. Then we're just going to do that type of thing through all of the instruments. So anything that I've done, let's see what I've done. I've done the vertical speed indicator, and that's basically the same type of thing. It's a needle that rotates, and I used it so that it starts on one end, and basically each one of the, so 5, so 360 degrees, but with this instrument, it starts 90 degrees to the right, and then it rotates around from the vertical speed down to the vertical speed up and over. So just to add a few keyframes for that. The turn and bank indicator, same type of thing. It goes from here all the way across to there. And basically the clock, well, the clock has 3 needles, so they all rotate 360 degrees. The RPM indicator, same thing. Manifold pressure is a half 1, so manifold pressure only rotates here. The fuel flow, CHT, EGT, and then I just grabbed a whole pile of graphics off the internet, and because we didn't have the ammeter and voltmeter, so these needles basically just rotate in a quarter of a circle. So we're doing the exact same thing over and over and over. So let's concentrate on these individual instruments, and I'll go into a little bit more detail. Like I say, they're basically the same thing, where you start, where you rotate around, etc. So the instrument needle vertical airspeed I get from the templates. So we had the vertical speed. Yeah, where is it? I think it was down at the bottom. There, needle vertical speed. Same thing, needle vertical speed subtemplate. Needle vertical speed subtemplate. The name of it is here, node ID, animation ID. Here we have a max value of 2000, okay? And the way it rotates is the vertical speed rotates based on a bias of 50. Remember that all animations are 100%, not necessarily 100 keyframes. And so there's a 50-50 chance. And in this, the reason is these numbers down here under 50% are negative 2,000, negative 1,000, negative 500 feet. And anything above 50% is plus. So the sim avar, which is used to get this, is brought in to do the calculation of what position the needle should be. So the needle in this particular case, I just started at 0 and went from this side all the way around to the other side. Gave it a name, and then did that. What I had to do for the actual interior XML, I put everything in instruments, component, and then I just basically use the template for each one of these instruments that Asobo has already created, making some minor changes to existing templates that are already in the simulator, and I used the Bonanza. So we have the airspeed, and the airspeed has a minimum value of 10 and a maximum value of 175. This gives you the 0 to 100% for the airspeed to go around all the way around 0 to 180. Same thing with the vertical speed, minus 3000 plus 3000. So I have to go into the vertical speed template and say that the max value is 3000 when you saw that the max value was already defaulted, excuse me, to 2000. So this is a default template parameter. If I don't change it, the default is 2000. I went into my interior XML for the vertical speed, made the max value 3000 now. The turn and bank indicator, well, it's not going to go around in 360, but it's going to be similar to the vertical speed indicator in that it has to start at a particular thing on a with a negative and then the positive. Well, here it's a turn one way and it has to turn the other way. So basically the turn and bank indicator is an indicator that shows you a turn and the turn rate, and their standard turn rate of 360 degrees in 2 minutes, 3 degrees per second, I think. Yeah. So all these calculations. So this is one step up now in complexity in that we also have the ball. So the ball is an animation, and all I did was eyeball it. So I took the animation for the ball and I said start here, and then I went over, and then I moved the ball over and down, and I went like this, and I moved the ball over and down, over and down, over and down, over and up, over and up, over and up. So I just eyeballed this animation. With your $1,000 add-on, you'll probably be a little more specific. But the, excuse me, turn and bank indicator, the middle position, the third position, is straight across, and anything lower than 50% is a left turn, and anything higher than 50% is a right turn. Now there's a little bit more math involved. The turn and bank indicator has a minimum value of 14.3 degrees and a maximum value of 14.3 degrees. So what that indicates is if we look at the details, turn and bank. Hopefully that's it. Turn and bank, instrument needle turn. So we got our ID for the needle, and we need an ID for the ball too. So there's two sets of node IDs and animation IDs. There's a warning. We don't have a warning in this particular instrument, and it's a lot more complicated. Here we have the condition for the needle animation, and we have min and max values for the default Asobo aircraft is a 6-degree tilt, while On my aircraft, I've decided to make it a 30 degrees, but the needle point at which you are at a standard rate is 13, 14 degrees. So rotating that airplane one way or the other by 13, 14 degrees, I'm a little bit off, is the number that you use for the min and the max values that you're going to use for your interior. So I'm using min and max 14 degree deflection is where the turn indicates that it's 3 degrees or a standard rate turn. So the next complicated instrument is going to be the clock. And the clock is complicated because, well, it has 3 animations. You've got a animation for the clock hours, minutes, and seconds. So I've got 3 different, I'm going to isolate everything here. I've got that guy, and you can see he's my second hand, and also that one, and also the hours. So I just shortened each one of them, and they go to 360 degrees. And I used a different way. I took the initial one, then 90 degrees, 180 degrees, 270 degrees, 360. So 0, 90, 180, 270, 360. And I did that, excuse me, for each of the different instrument or needles. Then let's have a look at the clock. Where did I put the clock? Oh, time clock, right there. So a little bit more. So the delta var's scope is an L var. So the instrument needle for the clock, the instrument, turn coordinator's gone. That, where have we got the clock anywhere? Awful lot of extra. There we are, clock. Clock. We get the node ID, animation ID for the clock, subtemplate, and that's not quite right. All right, correct. Needle current time clock. There's just too many here. Okay, what am I doing? I'm going into this. Ah, yes, okay. The reason is a lot more complicated in the base. So we have all of the different, so we have hours, minutes, seconds. We then have the node ID for each one of those. And then we have an adjustment knob. No, we don't have adjustment knob. And then all of the values here using the needle clock ID. And then we have node hours, node minutes, node seconds, and it uses the animation code in each one of these. So for hours, that component, that animation, using just that. Is there adjustment knob? Not going to go there. Okay. So that's what we have here, and that's all the calculations that are going to be used already for you to make the clock work. So 3 needles, 360 degrees, make them go around 360 degrees, and that's your clock. Okay, let's go to the engine instruments now. The RPM is a simple instrument again. So it's just a needle. The needle basically is set, and I use different specific keyframes for 0, 1, 20, or 200 RPM, 500 RPM. I'm a little off. Again, off. We'll see how that works. That's because I started at 0, and then I made 10, started at 0 again. So really that is not keyframe 5, it's the 4th keyframe, or the 6th keyframe, sorry. And that's why it's at 6. So I was trying different animation techniques starting at 0, making the first keyframe the same as 0 like we did for some of our switches. So I've been playing around with different ways of doing things. So RPM, there you go. You use specific keyframes for specific, not 360, but I made it go all the way to 31, so to speak. The next instrument I'm going to do is the combination of manifold pressure and fuel flow. Now, if you saw, what you might have is something here that is probably the copy of the altimeter is in that position. I deleted it, basically copied the RPM face over here, made it that, and I got a graphic from the internet for a dual gauge single dial instrument. So I've got 2 needles. They start in 2 different positions, and they're for 2 different instruments. So the manifold pressure, I made it go to 60 so that you would have 10, 15, 20. So just a way of doing that again, marking the keyframes in certain position. There's 10, there's 20, there's 30, there's 40, 50, and 60. So I just went every little bit. So each 10 keyframes is 5, 10, or like 15, 20, 25, 30, 35, 40, and I just did it that way. The keyframes are pretty lax, not lax, but you don't have to use 100. You can set it up as long as you understand that it's 100%. And the more keyframes, the better, to give you a much smoother animation. So that it, especially for levers and switches, for dials, probably makes it smoother also, etc. The fuel flow, same thing. I just did it in reverse. So there's the start, there's 5, 10, 15. So I went every 5 keyframes, but I kind of started offset a little bit. So it ends at a funny position. So the naming again for all of that, similar to what we've done before. So manifold pressure, using, that's the needle over there, fuel quantity, no, bus voltage, cylinder head, there, manifold pressure. Okay, min and max values had to be set. Fuel flow, min and max values had to be set to agree with your instrument. More engine instruments. This time we'll do fuel gauges, and there's 2 of them. So 2 instruments are going to do the same thing. They will have needles, and I made the needles here just move from 0, from the low end of the scale to the high end of the scale on both of them. So fuel quantity number 1, fuel quantity number 2, and then the different fuel gauges. So a separate fuel gauge just with different names and animations. And again, the animations are based on the fuel quantity. So fuel, I've got 2 of them. ID number 1, ID number 2, which has a tank ID of left main and the tank ID of right main, which is taken from the SDK. So the SDK has the information that will now allow you to name or use the proper name for the left main, right main guy. See if I can bring that up quickly. That would be in your config. So the sim objects, aircraft config, and where is that in the flight model? Yes, the flight model and the fuel system. So in the area here, we have left main, right main that are used, and that is the what you use inside the aircraft config. And these values are the tank IDs that are used in the AVARs, I hope. So programming APIs, simulation variables, aircraft sim vars, fuel variables. Do I have that? So here, yeah, so right auxiliary, left auxiliary, center, external, right main. See what the tanks have spacing here. So this information is plopped inside. When you look at the needle fuel quantity, we get, and that's why we went through the templates on how they work. So needle fuel flow. Do you see it? Point to it if you can see it. Fuel quantity. And then instrument needle fuel quantity. So the same type of thing, getting the animation here. Tank ID is set, and then the AVAR is made by sticking tank ID in the middle of the AVAR. So we went over this in how to decode all of this. So this tank ID is taken, say, so I have a tank ID. It's plopped in here to make it fuel tank, right main quantity, fuel tank right main quantity, so that we're using this AVAR here. So what you didn't see was when I didn't switch screens. Okay, the instrument subtemplate, we have the tank ID for the fuel quantity subtemplate. Tank ID uses that by plopping that variable into the AVAR that we used in the SDK. So a little bit more understanding, but it's a simple instrument, but it gets a lot more complicated when we start looking at all of the different templates. So you must understand how to decode all of the information in the templates, or you won't be able to use them properly and set the values properly. And that's why we set tank ID for these two things like that. So ID number 1 is our left tank, ID number 2 is our right tank. And that goes into those needle values. And again, low scale to high scale. Similarly, for what we'll do next is the oil and the ammeter, voltmeter, and a dual gauge for the EGT, CHT. So let's do the voltage and the ammeter or charging circuit. I grabbed some information off of the internet, and here we have the ammeter. Whoops. And we have the voltage 0 or 10 to 16 volts, and here is our charging. So 16 the load, 60 that we used in our sim object or the systems config file. So the systems config file, the circuit, the battery is a 14 volt battery. The alternator is a voltage alternator, and the curve is here 14 volts for the curve number 1, and load and voltage, curve number 1 and number 2, 70. So that's the information that you need to associate to these needles. And again, very simple. They just move top to bottom. This guy is probably just a little bit bigger because he doesn't, so he goes to 60. Ammeter, no underscore on this one. What do I have? I have no underscore on that one. And we go back to the interior and the clock, needle fuel quantities, ammeter, and bus voltage. So failure code 50, don't append. So I'm not appending the ID in this case. So the SIMVAR is the bus. The node ID I made, I can specify node ID and animation ID. If I don't want to use what is in that, I can specifically say use these. And the min max values 10 and 16 for the voltage, like you saw. Again, simple, but you have to be able to decode the instrument information that is in the fuel flow. There's lots to look at. Ammeter, here we go. Ammeter uses a minimum, maximum. So you could have a ammeter that goes into shows the discharging. The animation name here uses a suffix, but I decided not to use the suffix. So the ammeter interior ammeter, don't append the ID. So pretty simple. Just make sure you understand how to decode and add the proper values. So the last few instruments are the oil temperature and oil pressure, oil temperature, and similar. You're just making the needles go from the low end of the scale to the high end of the scale. The middle point here is your good point. Just happens to be where it is. And you do the same type of thing where you view the proper oil, and I'm not going to set anything here. Don't append, so there's no underscore. Create a highlight used for the checklist. Here I've got a min and a max value of 0 to 130 for the oil temperature in my particular case. Again, don't append, so there's no underscore 1 or anything, but the same type of thing involved. Okay, so another instrument buried way down here is the flap indicator. So again, it's just around an origin. You're just rotating different positions. So you kind of have to get this right, depending on what degrees your flap indicator is. You're in takeoff position or down. We have a 2-stage flap or 3-stage flap, cruise, takeoff, and down. Handling flaps, same type of thing. Flap indicator, do I have that? Where am I? No, flap. Handling flaps. So I think where did I put the flap indicator? In electrical? That's the flap levers. Oh, yeah, it is. So I put it down here because it's a handling element. That's why I didn't put in an instrument, because the Asobo template for it is a handling instrument. So I put it in the handling flaps component. There's nothing specific to say. You just set up the proper indicator in Blender, handling indicator flaps, and that's it. The other instrument we have is a compass ball. So set the origin to the middle, and you're going to rotate around the z-axis. And so basically you're just going to rotate 360 degrees. And name it instrument dial compass. And that's it. Okay, let's step it up a little bit. We've done a lot of instruments here, single needles, needles in a different direction, indicators, then engine instruments and so forth. Needles, 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 needles. The more complicated instruments are the attitude indicator, the HSI, It's not going to be a heading indicator. In our case, we've got a combination of heading indicator, VOR, glide slope localizer. That's pretty complicated. That'll be an entire episode on its own. Not doing any of the radios yet because they're JavaScript and Glass Cockpit like. We could do the CHT, their needles or regular needles. The second VOR, not going to do that. So we'll just do one mid-level instrument in that we have a combination of two animations and one is the parent of the other. So what we have to do is we have a number of pieces to the instrument, which is the attitude indicator. The attitude indicator has a bank action. You can see there's an animation associated with that. And there is a marker associated with that and a attitude indicator pitch animation. The marker just follows the bank. So if we turn off the pitch just for a moment and I run through that, you can see that the bank indicator is again a 100% instrument, 50-50. Banking one way, it turns one way. Banking the other way, it turns the other way. So you're going to make a bank instrument or a bank node that will turn left and right. The other instrument is the attitude indicator. I'm just turning off, let's see. So the attitude indicator moves up and down, so the pitch. So you want to go up, you want to go down. So the starting position for this is up and down, and the midpoint is level. So the midpoint is right in the middle here. Again, it's the instrument 50-50. Half of it is up and half of it is down. Now, knowing which half to worry about is the issue. So turning this back on and making the pitch instrument a child of the bank instrument, you'll see what happens as you bank. The object gets to a position where the middle, it is level. So in the middle, we're level, we're not banking, and we're not pitching. If I continue it, continues to bank and it continues to pitch. So you can kind of see how this thing turns and moves vertically as I do the animation. That's the difficult part. So you would make sure that you would create it. Hopefully I won't ruin anything, but I'm just going to take it out of, and you can see that one instrument is like that. Oh, I've ruined it. Let me just undo. All right, got it in the back. So you have to understand that you have to put this in the proper positions, and it's most likely in the middle where I take this out. Is it? Then I can go like that. It just happens to be moved in a position that's a little bit behind the other one. So Anyways, so that's what you have to do with that, and you give it the proper naming, and then we look at the information for the attitude indicator. So the instrument attitude indicator, or adds the ID, goes to the subtemplate attitude indicator. There's a legacy version, knob type legacy, so we're using the new version. So there could be a knob associated with it, but I haven't set that up yet. Just wanted to get it to work. Then attitude cage. So if we use caging, I haven't set it up with caging. So we have instrument attitude knob and instrument attitude indicator. So it's not legacy. So node ID, etc. So that's the knob attitude indicator. Attitude indicator simple is what we're using. So the attitude indicator simple, pitch degrees, animation, bank, bars, pitch and bank. So all of those different parts are set to what is required. So the combination of getting this instrument with that instrument is difficult. And what you're doing here is I made it a rounded instrument because in this particular case, the origins are off, not centered on the geometry. The only one is that rotation. So when they rotate, everything rotates and turns. That one rotates, and you have to make sure that they're the same. So this length has to be the same as that length, and I just happen to make them go to 36, 37, just to get it to work correctly. But they are simple to make. You should just be able to make them. I had to move them around after the animation so that one stays ahead of the other, so you get that look, the proper look when they're so horizontal, right in the middle position. The other instruments we got left is the ADF, which is a needle instrument, plus a card, plus a knob. And the knob will change the card, which is basically a way of setting this. So you set the direction that you're going, and then what'll happen is the ADF is tuned to a station, and it will rotate and show you where the station is compared to or in relationship to where your aircraft is. And the knob has to be used and has to have its animation, which controls the rotational animation here for setting. It's a little bit more complicated. I even think it's more complicated than the attitude indicator because you got a knob controlling another animation. So we've got 3 animations going and 1 with the other. But this won't work properly unless we have the ADF electronics working, unless we had one of these guys working. So I'm going to leave that. I'm going to keep that. This is a super complicated instrument. Just going to leave that also. The altimeter, this is what we were given in the aircraft. It's one of those drum ones with a needle. So again, it's in the wrong spot. I'm not going to do this one yet. Similar, we'll have a knob for the indicators here to set the pressure, to set the altimeter setting, etc. We can have this type of digital altitude readout, or we can have the 3-needle one, but I'll leave that as a separate video. One thing we did forget with the other was other levers was a fuel selector switch. So see if you can get this on your own. Just get a fuel selector switch and you basically have left, right, and off on the fuel selector so that you can drain the proper tank that we have the fuel gauges for. Like I said, the HSI is a super complicated instrument. We have a VOR indicator. Again, I didn't set that up. Object set origin. So that'll turn. And we got the they won't work either. So up and down movement for the glide slopes, plus and minus that. The VOR indicator. Haven't got that set up. So I'll leave that. Lots more, a couple of knobs to worry about that are going to move the indicator plus the course direction indicator also. Well, the only thing that's left is to export it out of Blender and see how your animations work. So that's what I've done. And I see that we have some good things going here. What have I got? So we have the RPM seems to be good. 1500, 1500. Okay. So moving the throttle moves my manifold pressure and fuel flow, EGT, stuff like that. My charging battery, fuel is half full, 50%, yes. My attitude indicator, my turn and bank, the ball, my airspeed, my flaps are in the correct position. So we've got a lot of things working here. Can I go anywhere? Turn the brakes off and let's see what happens. Airspeed is coming alive. Everything else is manifold pressure. Okay, flaps up, flap indicators coming up. I'm at 60 knots. I don't have an attitude indicator, but my 67, 70, yeah, pretty close. And engine instruments, oil pressure, temperature, things are looking good. And can I bank? Yes, my banking is correct. The compass is telling me what direction I'm going. And a little bit of a lag there. I'm going north, I guess. My vertical speed indicator is good, down and up. Yep. So my turn and bank indicator, keep the ball. Now I can use my rudder pedals. Oh, it's too much of a bank. So how many degrees per second? Can't tell, but my compass will tell me. And if I bring back the prop, I bring back the RPM, and I can bring back the fuel flow with my mixture. Everything seems to be working. Well, there you have it. Making your gauges in the aircraft add-on, more cockpit animations, more of the complicated stuff we'll get to later. Our next episode will complete these cockpit gauges and maybe the control column, rudder pedals, warning lights, breakers, window vents, doors. There's lots of work to do. Oh yes, even the clock works. What time is it? 10 after 3. It's taken me a while to make this video. So what about the big stack of instruments in the middle? Well, you're going to learn about the panel XML, the panel config, JavaScript, CSS, HTML, but that's in a further episode. That's a long way off, I think. I just think what we've got here is a good start with what you need, and we'll learn about all of these advanced topics at a later date. So enjoy your aircraft. You can fly it around now in the sim. And again, good luck and see you next time. Where am I going to go now? Here, a nice steep turn. Where's my airport? Where's my airport? I've lost it. Oh dear. Oh well. Enjoy.